Dear student, welcome back to the physics class. In the last session, I explained AC applied to the pure inductor and pure capacitor. Now, we continue that discussion. AC applied to the pure capacitor. Now, the equation for voltage V is equal to V naught sin omega t, where V naught is the amplitude or peak value of the voltage. And what is the equation for current through the capacitor? I is equal to I naught into sin omega t plus pi by 2. So, this is the equation for current, where I naught is the peak value of the current, and I naught is also given by, it is C omega into V naught. Now, if you compare equation for voltage and current, definitely they are not in the same phase, because it is omega t. Here what is the phase angle? Omega t plus pi by 2. Therefore, who is leading? Current is leading the voltage by how much? 90 degree. Phase difference is 90 degree. Therefore, we can say I leads V by pi by 2 radian or 90 degree. Now, we discuss about this I naught is equal to C omega into V naught. You take this equation and try to rewrite in another way, that is I naught is equal to V naught divided by 1 by C omega. So, this formula can be written like this: 1 divided by V naught divided by 1 by C omega. If you look at this formula, it is similar to now Ohm's law. What is Ohm's law? I equal to V by R. So, just by comparison, it is very clear the term in the denominator is similar to resistance in Ohm's law. Therefore, this term in the denominator we can say resistance of the capacitor for the flow of AC, but again we face the problem as in the case of inductor. What is the problem in the inductor? I said while discussing inductor, I said when alternating current flows through the inductor, it opposes it, but it never produces heating effect, it never consumes electrical energy. Same problem here also. Capacitor opposes the flow of AC, but it never consumes any energy, it never produces any heating effect. Therefore, the term in the denominator is not resistance. Instead of that, we say it is reactance, reactance of capacitor or capacitive reactance. Therefore, I naught is equal to V naught by XC, where XC is the capacitive reactance, and by comparison we can say XC is equal to capacitive reactance is equal to 1 divided by C omega, known as capacitive reactance. Therefore, now what is meant by capacitive reactance? It is a 1 mark question in annual exam. Capacitive reactance is the opposition offered by the capacitor for the flow of AC. Do not use the word resistance, do not say resistance of the capacitor for the flow of AC, no mark will be given, because resistance has got two properties, opposing and it consumes energy producing heating effect. Here only opposition. Therefore, capacitive reactance is the opposition offered by the capacitor for the flow of AC. Okay. Now, how to define it? rewrite this formula. If you take this equation, we can rewrite it. Xc is equal to, it is V naught divided by I naught. Therefore, how to define capacitor reactance? Capacitor reactance is defined as peak voltage across the capacitor divided by peak current through it. It is the ratio of peak voltage to peak current. This is also equal to Vrms by Irms. The reason is, for the numerator and denominator, you divide by root 2, it is not making any difference. What is V naught by root 2? Vrms. I naught by root 2? Irms. Therefore, V naught by I naught can be written as Vrms by Irms, which is also equal to Vm by Im. Mean voltage across the capacitor to the mean current through it. Therefore, there are three equations here in terms of voltage and current, but for definition purpose we take RMS value. So, how to define capacitor reactance? Capacitor reactance is defined as the ratio of RMS voltage across the capacitor to RMS current through it, and it is expressed in terms of ohms. Because it is the ratio of voltage to current, its unit is ohm. Now, you can write any one of them, but in exam it is better to write RMS value, because RMS value is the general value in AC. Now, take this equation, it is one more formula for capacitor reactance. So, take capacitive reactance is equal to 1 divided by C omega, which is also equal to 1 divided by, what is omega? 2 pi f into C. Therefore, capacitor reactance is also equal to 1 divided by 2 pi Fc, very important equation. 2 pi is a constant for the given capacitor, C is a constant, therefore, only frequency is variable. Hence, capacitor reactance is inversely proportional to frequency. Very, very important point for 1 mark. The question may be like this: how does capacitor reactance vary with the frequency of AC? You just say capacitor reactance is inversely proportional to frequency of AC. Now, put frequency equal to 0. What is the meaning of frequency equal to 0? Frequency equal to 0 means it is DC, that I already said. Because if frequency is 0, time period is infinity, means after infinite time AC changes the polarity, means it never changes the polarity, it is the DC. Therefore, for DC frequency equal to 0 implies that capacitive reactance, put frequency equal to 0, it is infinity. Therefore, capacitor always offers infinite reactance or opposition for the flow of DC, means it has got lot of opposition, it never allows DC. Therefore, capacitor never allows DC current to flow through it. Got it? It blocks DC. It is not allowing DC, means we can say it blocks DC, but it happens only after full charging, remember. Okay? Because in a DC circuit, up to the point of full charge, capacitor allows the current, that is known as charging current. After full charge, capacitor blocks DC because its reactance is infinity. Okay. Now, we plot the graph of frequency versus capacitor reactance. Again, it is a 1 mark question in exam. Plot the graph of variation of capacitor reactance with frequency of AC. This is the frequency along x axis. Here we take capacitor reactance, and we know when frequency is 0, it is infinity. Therefore, when frequency is 0, it is infinity, we can't mark, it is like this. But as frequency increases, it exponentially decreases. This is the graph. And never start the graph from y axis. Don't plot the graph like this. It is wrong, because it says that when frequency is 0, capacitive reactance is finite. This is the wrong graph. If you plot like this, no mark will be given in exam. Graph must be like this. Now, we plot the graph of voltage and current in the case of capacitor. Graphical representation followed by phasor diagram. So, even you have to plot the phasor drawing. Now, first of all, I want to plot phasor drawing, that is convenient. Later we go for graph. So, how to plot the phasor diagram? Now, what is the formula for voltage? V is equal to V naught sin omega t, and current is equal to I naught sin omega t plus pi by 2. Okay. Now, generally we plot voltage. So, this is the phasor drawing for voltage. V naught, and this angle is omega t. What about for current? Current I is equal to I naught sin omega t plus pi by 2. So, omega t plus pi by 2, another 90 degree from here. It must be in the anti-clockwise direction, because in anti-clockwise direction angle is positive, clockwise negative. Therefore, 90 degree ahead. Therefore, it must be like this, I naught. So, this is the phasor drawing for voltage and current in the case of pure capacitor. Okay. Now, this graph can be plotted like this also, no problem. It is V naught and I naught is 90 degree ahead in the anti-clockwise direction. Therefore, it is I naught. This is a simple phasor drawing. Both of them are rotated in the anti-clockwise direction. So, the phase difference between voltage and current is 90 degree. So, this also phasor drawing. This is one more phasor diagram. Now, graphical representation. V is equal to V naught sin omega t, and I want to plot the graph of voltage. This is T by 4, 3T by 4, and here it is voltage plus V naught, this is minus V naught, and here we will take both V and I. So, first of all you plot the graph of voltage. Now, after observing the graph of the voltage, we get the value of current and we plot it. Now, what is the equation for current? I is equal to I naught sin omega t plus pi by 2. Now, take time equal to 0. If you take a time equal to 0, here what is the voltage? 0. So, here also you substitute t equal to 0, that is voltage is 0, because sin 0 is 0, and current I is equal to, it is I naught sine time is 0 plus pi by 2. Sine 90 degree, sine 90 is 1, I is equal to I naught. Therefore, when time equal to 0, current is maximum. Let us say it is I naught here. Now, we take next interval, time equal to t by 4. Take t equal to t by 4, then voltage is equal to V is equal to V naught sine, what is omega? 2 pi by t into t by 4. So, t we can cancel and it is actually pi by 2. 2 pi by 4 means pi by 2. Pi by 2 means 90 degree, sin 90 is 1. Therefore, V is equal to V naught. That is this. When time equal to t by 4, voltage is plus V naught. Now, what is the current? We try to find out current. I is equal to I naught sine 2 pi by t into t by 4 plus pi by 2. So, this already we know it is a pi by 2. Pi by 2 plus pi by 2 means 90 degree plus 90 degree 180 degree, sin 180 is 0. Therefore, current equal to 0. Current equal to 0. Therefore, when time equal to t by 4, current is 0. This is the point. Graph goes like this. This is the graph. Take next point. Take t is equal to t by 2, half of the time period. V equal to V naught sine 2 pi by t into t by 2. T we can cancel, 2 we can cancel, it is sin pi. Sin pi means sin 180, sin 180 is 0, voltage is 0. So, that is this point. When time equal to t by 2, voltage is 0. What is the current? I naught sine 2 pi by t into t by 2 plus pi by 2. Now, what about this first term? T we can cancel, 2 we can cancel, it is pi 180 degree plus pi by 2 90 degree means 270. Sin 270 is minus 1. Therefore, I is equal to minus I naught. I is equal to minus I naught when time equal to t by 2. So, this is the plus I naught and it must be now minus I naught. So, that is this much. Here is the point, minus I naught. So, graph goes like this. Now, take next point. Fourth point, what is the time? T equal to, it is 3t by 4. V is equal to V naught sine 2 pi by t into 3t by 4. So, t we can cancel, 2 and 4 we can cancel, it is 3 pi by 2, 3 pi by 2. Pi by 2 is 90 degree, 3 times of that 270, sin 270 is minus 1. Therefore, V is equal to minus V naught. That is this point, minus V naught. When time equal to 3t by 4, voltage is minus V naught. What about current? I is equal to I naught sine 2 pi by t into 3t by 4 plus pi by 2. This is already said 270. This is 270 plus 90, 360. Sin 360 is 0. Therefore, I equal to 0. I equal to 0, that is this point. Now, last point, when time equal to t. So, point number 5, take T equal to capital T, voltage is equal to V naught sin 2 pi by T into T, that is T cancel, sin 2 pi. Sin 2 pi is 0, therefore voltage is 0, that is this point. When time equal to capital T, voltage is 0. What about current? I equal to I naught sin 2 pi by T into T plus pi by 2. So, here T cancels out, it is 2 pi, means 360 degree, 360 degree plus 90 degree. So, it is equivalent to sin 90, sin 90 is 1, therefore, it is I naught, I naught, therefore, plus I naught, therefore, the point is here, here. Now, we join all these points, that is the graph of current, and current, graph for the current is always represented by dotted lines. So, this is the graph of current and it is the graph of voltage. Now, I want to relate this graph with phasor diagram. So, extend this one. Now, see, this represents V naught. So, take almost the same length, because you have to plot phasor drawing where it is the rotating vector whose length is equal to peak value. Therefore, it is V naught. Take it here, just to make it convenient, we take the same length V naught. This is V naught. And it is omega t, remember. Okay. Now, take this graph to the, try to link this V naught with graph, that is here. It is nothing but instantaneous value. Actually, it is y component. Already I said, in the phasor drawing, y component always represents instantaneous value, that is this instantaneous value. Now, current, what about current? Current is 90 degree ahead. Therefore, this is omega t 90 degree ahead, omega t plus pi by 2. Therefore, it must be in this quadrant 90 degree ahead and its length must be I naught. Therefore, this is I naught, take the same length. So, this is I naught. This must be 90 degree. Now, if you take this, again its y component represents instantaneous value. This is y component of the current and take that one to the graph. This is I. Therefore, this represents instantaneous current, this represents instantaneous voltage. So, this is the way to link both graph and phasor diagram. Now, we discuss power in an AC circuit. So, power consumption in the AC circuit. What is the meaning of power in the AC circuit? Already know, it is the rate at which electrical energy consumed. We know whenever alternating current flows through the resistor or any other circuit, definitely that circuit consumes energy. The amount of energy, electrical energy consumed in 1 second is known as electric power. Now, we try to calculate or we discuss electrical energy consumed in 1 second in different cases. So, power in the resistor circuit. How to calculate power consumption in the resistor circuit? So, power in the resistor circuit. In the case of resistor circuit, we know voltage is given by the formula V naught sin omega t, and current is given by the formula I naught sin omega t. Now, if you multiply both of them, because already you know what is the formula for power, power is equal to V into I or I square into R or V square by R. Power is equal to V I, which is also equal to I square into R, which is equal to V square by R. So, we already know the equation for power consumption in the electrical circuit, and we have got this formula in current electricity. Now, here also we try to find out power. It is the instantaneous voltage, it is the instantaneous current. If you multiply them, it is known as instantaneous power. It is known as what? Instantaneous power. Instantaneous power. Pi is equal to Vi. But in a AC circuit, we calculate power consumed over the cycle, one full cycle of variation, and we know as voltage and current changes, even power consumption also changes, means instantaneous power consumption changes. Therefore, it is better to find out what is the average power consumed over the complete cycle or over one cycle. That is known as average power consumption. But how to find out average power consumption? So, in earlier topic current electricity or even in first PU, you studied about power. Power is nothing but rate of doing work, dW by dt, that already know. P is equal to dW by dt, or what is dW? dW is equal to, it is P into dt. And if you want to find out total energy consumed, because it is work done is also equal to energy consumed. Therefore, if you want to find out total work done, it is the integration dW is equal to integration P dt. But what is P dt? P means power. It is power at the given time. Therefore, in this case, instead of writing P, you write Pi into dt. And if you integrate, we get total energy consumed or total work done, nothing but energy consumed. Therefore, this becomes W is equal to, it is integration instantaneous power into dt. Okay. This already know in first PU. Now, I want to find out average power consumption over the complete cycle. So, P average is equal to, it is total energy consumed, we take it as W in this case, W means work done or energy consumed, divided by capital T. What is capital T? Time period is equal to, it is integration Pi dt divided by T. Therefore, in the case of AC circuit, average power consumed over the complete cycle, average power consumed over the complete cycle is equal to, it is integration of Pi dt divided by T from where to where? 0 to T. Therefore, if you try to find out average power, it is by the method of integration. But no need of carrying out integration, it is made much simple. Therefore, this even though it is the integration part is made very simple. Therefore, now we see what are the different integral values. We have got some standard values. So, if you remember those values, it is enough. Now, see here, you have got equation for voltage, for example, V naught sin omega t, and its graphical value, it is sine function, remember, sine function. Therefore, its graph must be like this. It is t. Now, what is the average value of the sine function over the complete cycle? Average value of the sine function over the complete cycle is 0. Therefore, if you integrate this one over the complete cycle, answer must be 0. That is written like this. It is the average value of the sine function over the complete cycle is equal to 0. Like that, you have got a cos function. Let us say another possibility is the cos function. So, the cos function, graph will be like this, already know. Again, what is the average value of the cos function over the complete cycle? 0, because for every positive value here you have got a negative value, and for every positive value here you have got a negative value. Whenever we add, answer becomes 0. Therefore, we write like this: average value of cos omega t over the complete cycle is equal to 0. So, whenever you are going for integration, if it is a sine function over the complete cycle, answer is 0. If it is a cos function, answer is 0. Now, sometimes you have got a square value, then how to integrate? For example, you have got an integration of sine square omega t. Now, this one, let us say V square is equal to V naught square sine square omega t. So, if you plot the graph of sine function, the sine function graph is like this, no doubt it is the sine function, but now it is the square of that square. Therefore, you have to take every value, every point is instantaneous value, square it. Think that square, the graph of the square value is like this. Think like that. It is the negative value, but its graph is like this. Even though negative value, square is positive value. Now, if you get the average of this square value over the complete cycle, can it be 0? No, because all of them are positive values. All of them are square values are positive. Its average value cannot be 0. Then how much it is? So, it is the average of the sine square omega t over the complete cycle, it is always equal to half. Therefore, whenever you are doing some integration with the function sine square omega t over the complete cycle, its average value is how much? Half. What about another possibility, cos function? Let us say V is equal to V naught into cos omega t. Think like that. V is equal to V naught into cos omega t. Square this one, V square is equal to V naught square cos square omega t, and we have to do the integration, next step. Now, if you plot the graph of again cos function, the graph of cos function is like this over the complete cycle, and its a square value. Square value means, think that square value, the graph will be like this. Here every value is a negative instantaneous value, but square value is positive. Think that graph will be like this. Graph, it is the instantaneous value, its square values here, and again it is the instantaneous value, its square value, let us say it is like this. So, this graph represents square value, let us say. Then what about its average value? Its average value cannot be 0. Therefore, if you do this integration over the complete cycle, it is written like this: average of cos square omega t over the complete cycle, answer is half, value is half, remember again. Therefore, you ought to remember 4 standard values. 1, integration of sine function over the complete cycle, answer is 0. Integration of cos function over the complete cycle, answer is 0. Integration of sine square function or cos square function over the complete cycle, answer is half. You have to remember these 4 standard values, then integration is very simple. Now, you come back. Power in the case of resistor circuit. So, voltage is given as V is equal to V naught sin omega t. Current this. Instantaneous power P I is equal to V into I. Now, I want to find out average power consumption over the cycle, that is P average is equal to, already I said it is integration P I dt from 0 to t divided by capital T, where capital T is the time period. So, substitute 0 to t, what is instantaneous power? V into I. What is V? V naught sin omega t into I naught sin omega t dt divided by t. P average is equal to V naught and I naught are constant, take them outside, remaining is integration 0 to t, it is sin square omega t dt between 0 to t. Okay. Now, look here, it is the integration of which function? Sin square function over the complete cycle. It is nothing but average value of sin square function over the complete cycle. Therefore, it is written as V naught into I naught into, it is sin square omega t over the complete cycle, that is equal to V naught into I naught. What is the value of this? It is a square function, therefore, it is half, or P average is equal to, instead of writing V naught I naught by 2, we can write it as V naught by root 2 into I naught by root 2. What is V naught by root 2? VRMS. I naught by root 2, IRMS. Therefore, it is VRMS into IRMS. Therefore, average power consumed when alternating current flows through the resistor over the complete cycle is equal to VRMS into IRMS. P average is equal to VRMS into IRMS in the case of resistor circuit. Now, we can further simplify this one. We know VRMS in the case of resistor circuit, VRMS equal to IRMS into R, nothing but Ohm's law, V equal to IR. Substitute there. Therefore, P average is equal to, instead of VRMS, we write IRMS into R into IRMS. P average is equal to IRMS square into R. It is the one more equation for the power consumption when alternating current flows through the resistor. It is the first equation. It is the second one. Even we can write one more formula. What is that? See here. Here you do one thing, you multiply and divide by R for this equation. So, P average is equal to I RMS square into R square divided by R. I am multiplying by R and dividing by R. But what is this I RMS square into R square? It is nothing but V RMS square by R. It is nothing but Ohm's law. V is equal to IR. Voltage is equal to current into resistance. Therefore, we have got one more equation, that is P average is equal to V RMS square by R. Therefore, there are three different equations to calculate average power consumption when AC flows through the pure resistor. Now, all the three equations, if you see all three equations, we feel that we know all the three equations, because in current electricity we have got a formula to calculate power consumption, and if you look, these three equations are similar to those three equations. For example, it is P average is equal to VRMS and IRMS. What about in a DC circuit? VI. In a DC circuit, remember, power is equal to VI. It is similar to that. Look at this formula, P average is equal to IRMS square into R. It is similar to equation P is equal to I square R in a DC circuit. And what about this? This is similar to power is equal to V square by R. Therefore, in the case of resistor, the equation for power consumption is similar to expression for power consumption in the case of DC circuit, with the one difference. What is the difference? Here you have got a voltage across resistor V, DC voltage. Here you have got a RMS value. Here it is a DC current through the resistor. Here IRMS means wherever you have got a DC voltage, you have got a VRMS. Wherever you have got a DC current, you have got IRMS. Therefore, RMS values are known as DC equivalent value. RMS values are known as what? DC equivalent values in terms of power consumption when AC or DC flows through the resistor. And moreover, interesting point, if you take a pure resistor, you connect that one to a DC circuit. In a DC circuit also it consumes energy, it produces heating effect. You connect the resistor to the AC circuit. In the AC circuit also it consumes energy and produces heating effect. Therefore, DC or AC, both of them, they produce heating effect in the case of resistor circuit. And this average power consumption over the complete cycle is also known as true power consumption, is also known as what? True power consumption, means actual, it represents power consumption over the complete cycle. Okay? Therefore, in some of the books, instead of writing P average, they write P suffix T. T stands for true power consumption. PT is equal to VRMS into IRMS. Next step, power consumption in the case of pure inductor. So, power in a pure inductor. Or energy dissipated in the case of a inductor circuit. Here voltage across the inductor V naught sin omega t. current is given by I naught sin omega t minus pi by 2. This already these two equations you know, and we say voltage leads the current by 90 degree or voltage lags current lags voltage by 90 degree. Again we calculate instantaneous power, means power consumption at the given time, it is equal to V into I, instantaneous voltage multiplied by instantaneous current, but it is better to find out average power consumption over the complete cycle, over the cycle. So, P average, next step, P average is equal to, it is integration of P I dt divided by T from 0 to T. It is integration Pi means Vi dt by T over the complete cycle, that is 0 to T. What is the equation for voltage? V naught sin omega t, V naught sin omega t into I naught sin omega t minus pi by 2 dt divided by T. P average, take V naught and I naught outside, V naught into I naught outside, then integration 0 to T, it is sin omega t into this sin omega t minus pi by 2. You do one thing, you take minus sign outside. If you take minus sign outside, then it is a sin pi by 2 minus omega t dt over the complete cycle. What is this? Sin 90 minus theta. Sin 90 minus theta is cos theta. Therefore, it is written as V naught into I naught. Minus sign can be taken outside. Therefore, it is a minus V naught into I naught integration 0 to T. It is sin omega t into cos omega t dt divided by T. That is minus V naught into I naught. Look at this, it is nothing but sin theta into cos theta. We know the formula, sin 2 theta is equal to 2 sin theta cos theta. Or what about sin theta into cos theta? It is sin 2 theta by 2. So, sin omega t into cos omega t is nothing but sin 2 omega t by 2. Therefore, write it. It is integration 0 to T sin 2 omega t by 2 into dt. I am writing capital T here, it is not making any difference. So, minus V naught into I naught by T integration sin 2 omega t by 2 into dt. Okay. Now, take 2 outside, minus V naught into I naught by 2, and what is this? It is the average value of sin 2 omega t over the complete cycle T. T can be shifted to here, and we know average value of the sine function over the complete cycle is how much? 0. If this term is 0, then the full product of this equation becomes 0. Therefore, what is the average power consumed? Average power consumed is equal to 0. Hence, over the complete cycle, pure inductor never consumes any energy. That is why its opposition is known as reactance, not resistance. Now, we see one more case, power dissipated, average power dissipated in the case of capacitor circuit. So, power dissipated in the case of capacitor. Capacitor circuit. In the case of capacitor, V is given by V naught sin omega t and current is given by I naught sin omega t plus pi by 2. But we know it is sin 90 plus theta, sin 90 plus theta is cos theta. Therefore, it is I naught cos omega t. It is the equation for current and it is the expression for voltage. Now, we find out what is the average power consumed. Average power consumed is equal to, it is integration of instantaneous power divided by capital T. Integration of 0 to t V I dt divided by capital T. It is integration V naught sin omega t into current I naught cos omega t dt by t. So, take V naught outside, I naught outside, even we can take t outside. It is the integration of sin omega t into cos omega t, that already said. It is sin 2 omega t dt divided by 2. Now, we can take 2 outside, therefore, it is V naught I naught by 2. And what is this? It is the average value of the sin 2 omega t over the complete cycle. What is the average value of the sine function over the complete cycle? 0. Therefore, answer is 0. Hence, average power consumed when alternating current flows through the capacitor is always 0. Therefore, its opposition is known as capacitive reactance and it is not resistance. Therefore, remember one important point, when AC flows through the 3 components, resistor, inductor, capacitor, heat is produced only in the case of resistor and there is no power consumption, there is no production of heat in the case of inductor circuit and capacitor circuit.